Hi, welcome to the video tutorial for a lesson called Gardens, Patterns in the Garden, Two-Step Relations that is within the functions strand because it serves as an introduction to I equals mx plus c. Some lessons in the Thinking Maths pack are irreplaceable because they do something in the minds and the perceptions of children that I couldn't do myself. They just introduce children to concepts just perfectly, and I get that feedback all the time that they were able to do so much in this lesson, and really that is the strength of the work of Michael Shearer and Munda Adami, who wrote the Thinking Maths lessons. They've tapped into something that's very, very powerful. So this lesson, and I like this lesson a lot, it's one of my favourites and I've taught it many times, fits very well into many classrooms maths classrooms where you have posters of patterns on the walls, and you could focus on the fact that the ability to spot patterns is maybe what enables people who are good at maths to earn money. It's not knowing facts, it's being able to spot patterns, it's being able to represent patterns, it's being able to describe patterns, and so on. So this one involves the patterns in a plant. And so I would always draw it on the board and name it with the pupils. So there's a part of preparation where the children have to understand the names of parts. So you would say, here's my plant, and I'm wondering what we can call this bit. Children call it anything, but usually it's called the stem. And I might draw this in front of them, but I'm not very good at drawing, so it's easier if I draw it beforehand. So we've got the stem, and coming off the stem we've got branches, and then off the branches we've got twigs. And they quickly realise that these are leaves. So they know all of the terms, and you can then throw in the problem that, well, hang on this branch, how many leaves are there? And how many twigs are there? So in this branch, twigs equals 2, leaves equal 1, 2, 3, 4, 5, 6, 7, 8. This lesson works in lots of interesting ways because you've got a sense of there's a visual perception of a pattern. The children then count, so they've got 2 twigs and 8 leaves. They then try and describe the pattern, because what they then do is they go through the rest of the plant, and on this one there are 5 twigs. On this one you've got to choose, so the children draw their own number of twigs. There's confusion over these two. Don't focus on it too much, but the idea is that these aren't on twigs, but there's still 2 of them. Because often there's have a little stalk there, and the pupils will call that a twig, but you've agreed that this is a twig. And they can see that there's something in this fact that every twig has 3 leaves. Over here, there are 3 twigs, I think, and it gets all the way down to the last one, where there are 100 twigs. And obviously you want the pupils to work through the pattern, seeing that you count the twigs, count the leaves, and start looking for number patterns. Eventually they get to the 100 ones. Some of them do try and draw it, so it looks a bit like a hairy caterpillar. But others will say, well, actually, for 100 twigs, we think there's 300 leaves. Or 302 leaves. And the discussion is based around how they describe the pattern that they've spotted and how they say it. So often I might start the discussion, if I know that some have got 300 and some have got 302, they say, well, okay, when there are 100 twigs, what's the answer? Oh, 300, 302. And you invite pupils to explain how they've worked it out, and they start seeing the pattern. They start saying things like, well, I know there's more leaves than twigs. They'll say things like, there are always 3 leaves per twig. Others will say variations of this, but then some will say, don't forget the 2. Because you've got to add 2. You've always got to add 2, because on a twig there might be 3 leaves, but there's always 2 here. So if there's 1, there's 5. So you can explore through the numbers, you can explore through the patterns that the people spot. But by now you will have lots of different ways, 5 or 6 different ways of saying the pattern. It's lovely to explore several ways. It's lovely to say to a child, oh, say that again. Get a child to say something 3 or 4 times. It's lovely because every time they say something, they change it. And I think it's worth focusing on that the more, the ability to articulate your thinking is really quite an important skill. And often I'll highlight and make a show of the fact that a child starts to say something and runs out of words. And I'll say, actually, you're thinking, because your words are struggling to come out to keep up with your brain. And it's lovely to celebrate that. And a child might say something tentatively, you say, go on, say it. You know that they've thought something, and you just say, go on, say it. Doesn't matter, just say it. You're focusing, you're cueing in from the class. You're seeing which children have got it. You're cueing in from this discussion that they know it's got to be 302, but they're focused on the times by 3. So at that point, you start focusing on, well, actually in maths we write things shorter, we use algebra. How can we reduce this? And this can be a very, very rich time. This part of the lesson can take a while. The second part happens very, very quickly. Because what you want them to do is you want them to move from the visual patterns to the number patterns to actually articulating it and then to coming up with a formula. So you get all sorts of variations of some children will do the leaves equals twigs times 3 plus 2. Some will say leaves equal twigs times 3 plus 2 leaves. Others will do variations of L equals T times 3 plus 2, L equals 3 times T plus 2, L equals 3T plus 2. There's lovely opportunities to talk about what that actually means from the point of view of the pupils. And to talk, what have we got here? What is this? And name it as a formula, as an equation. Let the pupils name it. They could say, it's Aaron's way of writing it down. It's Aaron's formula. Fine, they've constructed the formula for a line from here. As I said, this can take a while. The next bit happens very, very quickly because you move on to a tile pattern where you have a dark tile surrounded by some white tiles. And what's interesting is this part of the lesson ends with agreement that this is a really good way of writing things down. That's fine. Look what you've done, Year 7. This is brilliant. So, okay, can you use Aaron's formula to talk about this pattern? And very quickly, this can take 5 minutes. Often before you've given the sheets out, pupils have finished this activity. And you'll hear pupils say, oh, you double it and add 1. You say, well, I want you to write down this formula in the same way as we agreed the other, whatever that was. I mean, it might be that, or it might be 3 times t plus 2 equals L. It doesn't really matter. We're not picking hairs here. We're getting them to symbolise a mathematical relationship. So very quickly they'll say, oh, double it and add 1. So they'll say, double it and add 1. So, well, how do I write that down? They'll say, the white tiles equals 2 times b, add 1. And you say, how do you do it so quick? That's fantastic. Oh, like I say, this often is finished before you give the sheets out. And it's worth celebrating that, the speed. This seems a really good way. And then you say to them, hang on, what do we notice about it? It just depends how they've written it down. They might write it down like this, or they might write it down like that. Doesn't really matter. And you can talk about rearranging it however you want, depending on the class, depending on what they bring to it. But you ask them to say, what's similar? What do they notice about this way of writing it down? And then the third part of the lesson, which I think is always worth getting to, is where they plot a graph of this equation. So you've got L equals 3t plus 2, W equals 2b plus 1, and sometimes it takes them a while to plot the graph, so you could do it for them. So you end up with that. And the question then is, and I've had classes where I've got really frustrated because they're trying to focus on drawing the graph. You say, okay, put your graphs down, look at that, tell me what you see. Who sees something in that? There's the Aaron's formula. This is just a line. All the graph is a line. So there's a formula, there's a line. What can you see? And it's a real privilege at this point in the lesson for the children when the children start to see things. They say things like, they'll often say, this line is steeper, this line is longer. just because it's actually going up higher within the space. But they'll say, this one's steeper. Why is that one steeper? Oh, it's going up in 3, sir. I mean, these are the things people say. Often it takes a while to say it. Oh, that one's going up in 2s. And they'll say, oh, the 3 there is what you go up in. The 2 there is what you go up in. Others talk about the intercept. Oh, add 2, it's 2 there, it's 1 there. Oh, that's interesting. Oh. They say, okay, I'm going to give you a new pattern, could you draw it? C equals 4y plus 6. What would that look like? Well, it goes up in 4, so it starts at 6. You say, well, does it matter what letters we use? Let's just use x and y. So you can say y equals 6x plus 4. What does that look like? You say, hang on, how come we've got from this, drawing patterns in a plant, to this? What's that about? My year 10s have just been doing that. My year 9s are doing that, and you're in year 7. What do you see when you think about this? And I think it's a lovely chance for them to reflect upon the thinking and to articulate what they now know because they are seeing things differently. I think that's important that you've made a breakthrough into a key area of maths.